Good day, viewers. Welcome you again to today's class. My name is Dr. Chris Esekaibe. I will be taking you part 2 of measures of central tendency. I brought part 1, which was measures of central tendency for ungrouped data. We looked at a particular example, and at the end of the day, we solved a series of a particular problem, calculating the mean, the mode, and the median. We also saw the advantages and disadvantages of the mean, the mode, and the median. Then we also took an example of an ungrouped data with an outlier. We saw how the outlier affected the mean so badly. Now again, I now dropped this particular problem with us to see how we can calculate the mean, the mode, and the median with and without the outlier. I gave this for a practice and promised to bring the solution to us when we meet for the part 2 of measures of central tendency. Today, we shall be looking at measures of central tendency part 2, the mean, the mode, the median for the grouped data. But before I go into that, let us quickly look at the solution of this particular problem. Now, there is no doubt that the outlier for this particular problem is 3. The outlier is 3. Now, if we want to calculate the mean with the outlier, we are going to have it as the mean with the outlier will be x bar is equal to 95 plus 90 plus 93 plus 93 plus 91 plus 96 plus 3 plus 94 all over the total number, which is 1, 2, 3, 4, 5, 6, 7, 8 all over 8. So our x bar will now be equal to, when you add that up, you are going to have 655 over 8. 655 all over 8. And that is equal to 81.88. 81.88 to 2 decimal places. That is the mean. Now, for us to get the mode is the one that occurs most. Simply, if you look at it here, which particular value occurs most, you will find out that 93 appears twice. So our mode here is 93. Then for the median, we are going to arrange the data in an increasing manner or a descending manner. So we start by having 30, 90, 91, 93, 93, 94, 95, and 96. Now the total number of observations here is 8. So we are going to have 2 numbers at the middle. So you count 3 this side and you count 3 this side. So our median is equal to 93 plus 93 all over 2, and that is equal to 93. You can see that our mode is 93, the median is 93, and the mean is 81.88. You can see how the median takes care of the outlier. The outlier will definitely be an extreme value. Here is at this extreme. So the other, the mode is the one that occurs most. Then at the end of the day, you see that the median has been able to take care of the outlier, but the mean has been affected by the outlier. When you calculate the sum, you will see that the sum was reduced drastically. The 3 here is an outlier, so this the value for the mean, the mode, and the median with the outlier. Now let us calculate. We'll keep these values aside. We are not going to calculate the mean, the mode, and the median without the outlier. Note the outlier here is 3, so we are going to calculate the mean, the mode, the median without the outlier. Now we are going to have our mean x bar is now equal to be is going to be 95 plus 90 plus 93 plus 93 plus 91 plus 96 plus 94. We are not including the outlier now, so this makes it a total number of 7. If you add this together, you are going to have the sum of 652 all over 7. This will now give you 93.14. So again, the mode still remains 93. Then now, if we want to order the set, arranging it in an ascending order to get the median, we are going to have it this way. We are going to start from 90, 91, 93, 93, 94, 95, and 96. Now the number of observations here is 7. It means it's an odd number. It means you are going to have one value at the middle. So you count 3 down here, 1, 2, 3. You count 3 from the other side, 1, 2, 3. Then the median is now 93. So median is equal to 93. You can see that without the outlier, the mean now is now close to the median and the mode. But the outlier shifted it. Now we are going to make a comment by doing comparison of results. We are now going to put the results in a summary. We are going to put the results in a summary. So here we have without outlier, our mean without the outlier, our mean is equal to 93.14. Our mode is equal to 93. Our median is equal to 93. Now with outlier, you will see that our mean is equal to 81.88. Our mode is equal to 93, and our median is equal to 93. Note our outlier is equal to 3 from the set of data. You can see the summary of results. What does this tell? It tells you that the mean has greatly been affected by the outlier. Without the outlier, the mean is 93.14, which is almost the same, approximately the same with the mode and the median. But with the outlier, the mean has been affected. You can see it has reduced from 93.14 to 81.88. And if you can recall the advantages and disadvantages of the mean, the mode, and the median, the main disadvantage of the mean is that the mean is affected by an outlier. An outlier is an extreme value. So this is the solution of the work I gave you guys to do, so you can make your correction. And now we want to go to the business of the day. The business of the day is looking at the mean, mode, and median for grouped data. So permit me to wipe this off so that we can go to the business of the day. The mean, the mode, and median for group data. So we are looking at measures of central tendency today, part 2. Part 2. So we are looking at the mean, mode, and median for grouped data. For grouped data. Now, if you can recall the frequency distribution table that we created, I told you at the end of that video that we are going to use that video, the data set, to calculate the mean, the mode, and the median. Once again, I want to appreciate you for watching my videos. Please subscribe to my YouTube channel, Dr. Chris Esekaibe Mathematics/Statistics channel. Dr. Chris Esekaibe Mathematics/Statistics channel. Please, as you subscribe, you will see a bell button by the side. Click on the bell button. The bell button, when you click on it, it will notify you anytime I upload a video in that channel, so that you can continue with my series. The essence of this channel is to make mathematics and statistics easy. The essence is to make mathematics and statistics easy. The topics, the dreaded topics in mathematics and statistics, to make them easy. That is the essence of this channel. As you follow through, I believe you are going to get some things. And if there is any topic you have in mathematics that is giving you challenges, you can make comments and tell me to teach on those topics and upload the video. If you want to consult me, you can consult me on any area. My area of specialization in mathematics is numerical analysis. My first degree is on statistics, BSc statistics, MSc mathematics, and PhD mathematics. So you can consult me. I'm a consultant in mathematics and statistical analysis and numerical analysis. You can consult me with any problem, then we'll put our heads together and get the solution. So let's go back. Please also try and share my videos on your social media platform, your WhatsApp status, your Facebook, and the rest of them. As you do, God will bless you. So now let's go back to the data that we created, the data set, the group data we created from the 30 observations when I taught on how to create a frequency distribution table. Now the class and the frequency. Just listen attentively as we run through it. The first class is 6 to 10. The next one is 11 to 15. The next one is 16 to 20. The next one is 21 to 25. The next one is 26 to 30. The next one is 31 to 35. And the next one is 36 to 40. There's the class. And also we have the frequencies. For the first one, the frequency is 3. This is 5. Then the third one is 9, 5, 4, 1, and 3. If you can remember, this is the table we created from the 30 observations we had when we considered how to create a frequency distribution table. Now we shall be looking at the mean first of all. In that video, I remember talking about the advantages and the disadvantages of the mean, and we picked an example for the ungrouped data. We calculated the mean, the mode, and the median. We also looked at how the outlier can affect the mean and how the outlier cannot affect the mode and the median. Now, the first thing you do in statistics when you have a problem, the first thing is to write the formula correctly. The formula for the mean for grouped data. We are looking at, the formula is x bar is equal to summation f of x all over summation f. Let me write it again. X bar is equal to summation f of x all over summation f. This is the formula for the mean. The sum of, that means by implication we need a column for x. X is always called the mid value. The mid value is x. So we create a column for it. How do I get the mid value, the x values? Because the formula simply means f stands for the frequency, while x stands for the mid value from the class interval. Now the mid value, how do I get the first mid value for this class 6 to 10? I will add the two values. This is the lower class and the upper class. I will say 6 plus 10. When you divide it by 2, 6 plus 10 is 16, divided by 2, you will have 8. Then the next one, 11 plus 15, when you divide it by 2, you have 26. When you divide it by 2, you have 13. Then the next one again is 16 plus 20. You add it together, you get 36. When you divide it by 2, you get 18. 21 plus 25 is 46. When you divide it by 2, you divide 46 by 2, you have 23. Then the next one, 26 plus 30 is 56. When you divide it by 2, you have 28. Then the next one, 31 plus 35 is 66. When you divide 66 by 2, you get 33. Then the last group, which is 36 plus 40, which is 76. You divide it by 2, you will now get 38. So this is how we get the values for x. They are the made values. Now remember again, the formula, let me write it clearly so that you can see it. The formula for the main is x bar is equal to summation f of x all over summation f. That is the sum of the frequencies. Now again, the sum of our frequency is 30. You add the frequencies together, 3 plus 5 plus 9 down, you have 30. Now we are going to bring what we have in the table, in the formula, to the table. The formula says f of x. You bring f times x, you create a column for it. We are going to multiply f by x. So the first one there, you say 3 times 8 is 24. The second one, 5 times 13 is 65. Then 9 times 18 is 162. 5 times 23 is 115. Then the next one, 4 times 28 is 112. Then 1 times 33 is 33. 3 times 38 is 114. Now you come and sum it together. You add 24 to 65 to 162. You will now have a total of 625. 625. You sum it up. So the main x bar is equal to, okay, let me write it here. The main x bar is equal to 625, which is the sum of f of x, which is 625 all over the sum of f all over 30. So by implication, the main x bar, I always leave my answer in 2 decimal places. It will now be 20.83. 20.83. That will now be our mean for this set of grouped data. That is what will be our mean. Now, for us to calculate the mode has a formula. It has a formula, and the formula for the mode is given as mode is equal to L plus F0 minus F1 all over F0 minus F1 plus F0 minus F2. Then you put a bigger bracket times C. This is the formula for the mode. It is very easy to know the modal class. Now, the mean that we have calculated has fallen into a particular class. We will get to that when we finish. Now, for us to note the modal class, we'll go to the frequency and check the one that has the highest frequency, the group or the class that has the highest frequency. And that class will now become our F0. From the frequency, you see that 9 is the highest frequency. So we'll now call this our F0. Then the one on top of it will be F1. The one below it will be F2. Then, from the modal class, we have the lower. So before we go into that, it's good we have what we call the class boundaries. So we can get the class boundaries from here like this. Now, how do I create class boundaries? When we're creating the frequency distribution table, I told you how to create a class boundary. Now, the first class boundary from this particular first class here, you subtract 0.5 from the lower class and add 0.5 to the upper class. So this will be 5.5 to 10.5. This will be 10.5 to 15.5. Then this will be 15.5 to 20.5. This will be 20.5 to 25.5. This will be 25.5 to 30.5. This will be 30.5 to 35.5. And this will be 35.5 to 40.5. 35.5 to 40.5. 35.5 to 40.5. That's what you have there. So having this, it will help you to, what the class boundary does is to expand the boundaries so that more values can be accommodated into each group. You subtract 0.5 from the lower class. Every class has a lower class and an upper class. For this first class now, the lower class is 6. The upper class is 10. So you will subtract 0.5 from the lower class and add it to the upper class. That's what we do to get the class boundaries. Having gotten this, it will now be easier for us to calculate the mode. Now, we already have the modal class. The modal class is this class. That's the modal class. So when you calculate the mode, it is expected that the value for the mode will fall within that class. This is our modal class. The modal class is now between 15.5 to 20.5. So that is where the highest frequency is. So now let us go ahead to calculate the mode. Our mode will now be equal to the lower class for it. L stands for the lower class is 15.5 from. So everything we are looking at will get from this particular class. It's our modal class. Everything we need is there. So now we are using the lower class from the class boundary, not this one. Because this is the main one that has been expanded so that it can accommodate more values. So this will now be 15.5, which is a plus. Our F0 is 9. So you open a big bracket, 9 minus F1 is 5, minus 5, all over 9 minus 5, plus F0 minus F1. Then F0 is still 9 minus, our F2 is also 5. So the F0 is the frequency, the highest frequency. The one on top of it that precedes it is F1, while the one after it is F2. So the F2 is also 5. 9 minus 5, you cover the bracket, then times 5. Our class width is 5. From 6 to 10, I told you 6 to 10, you count 6 inclusive, 6, 7, 8, 9, 10. You can see the difference clearly from the class boundaries. 10.5 minus 5.5 is 5. Any one of them, you see that the class width, the class size is 5. 35.5 minus 30.5 is 5. 40.5 minus 35.5 is 5. So now our mode will now be equal to 15.5 plus 9 minus 5 is 4 all over 9 minus 5 is 4. 9 minus 5 is 4 plus 4, then times 5. So our mode is equal to 15.5 plus 8 plus 4 over 8 times 5. So mode will be equal to 15.5 plus 20 over 8. 4 times 5 is 20. So mode is equal to 15.5 plus 20 divided by 8. 20 divided by 8 is 2.5 plus 2.5. So mode is equal to 15.5 plus 2.5. Our mode will now be 18. You see, our mode is 18. We can clean the main so that we can have enough space to write the mode clearly. Okay, let me write it again clearly so that it can be clearly seen. Let me write it clearly so that it can be seen. So from here, our mode is equal to 15.5 plus, now you open the bracket, 4 times 5 is 20, 20 all over 8. So our mode is equal to 15.5 plus 20 divided by 8 is 2.5. So mode, our mode is equal to 15.5 plus 2.5 is 18. Remember, our main was 20.83. Now our mode is 18. This is the formula for calculating the mode. This is how the mode is calculated. Now again, the last measure of central tendency that we shall also look at is the median. Permit me to also clean this part of the board so that we can calculate. I hope the mode is properly taken. You have taken note of it. So you play the video over and again so that you can get the message clearly. Very, very clearly. Now, I want to write on the median. Before you write on the median, you must have what we call the frequency, cumulative frequency column. The cumulative frequency column is very important. Let me first of all write the formula for the median. The median is equal to, let me put it back a little. The median is equal to L plus summation F over 2 minus cumulative frequency of before the median class all over the frequency of the median class times C. This CF here means cumulative frequency. So we need to create another column for the cumulative frequency. The cumulative frequency is very simple. You start with the first frequency here, which is 3. We did it when we were creating this table. 3 plus 5 is 8. 8 plus 9 is 17. 17 plus 5 is 22. 22 plus 4 is 26. 26 plus 1 is 27. 27 plus 3 is 30. So you must arrive at the sum of the frequency. If you don't arrive there, then there is a challenge. Again, before we get the median, we must get the median class. And using the median class, the median simply means sharing the data set into two equal parts. So you are sharing the sum of f all over 2. This is the determinant that we use. And the sum of f is this is equal to 30 over 2, and that is 15. Now you are coming to use the cumulative frequency column to trace that median class. From here is 0 to 3. Once it passes 3 to 8 is this place. Once it passes 8 to 17. So this class also now is now the median class. So the median class falls in the modal class. It falls in the modal class. So everything we need to get the median will be gotten from this class. Now let us calculate the median. The median is now equal to our L, again, is the lower class. Normally you will get it from the class boundaries. Is 15.5 plus, then you come here now, we have already calculated our solution, f over 2, which is 30 over 2, which is 15, minus this CF means cumulative frequency B, the subscript B here means before. The cumulative frequency before that, this is the median class, the cumulative frequency before it is 8. So 15 minus 8 all over. Then this Fm means the frequency of the median class. Fm means the frequency of the median class. This is the median class, and that frequency is 9. Then now say times 5. Our class width is 5, which is C. So our median is equal to 15.5 plus 15 minus 8 is 7. 7 all over 9 times 5. So our median will now be equal to 15.5 plus 7 times 5, 35 over 9. So our median is equal to 15.5 plus 35 divided by 9. 35 divided by 9 is 3.89 plus 3.89. So our median, when you add 15.5 to 3.89, you are going to get 19.39. So our median is 19.39 approximately to 2 decimal places. So this is how the median is calculated with the help of this formula. The first thing you do is to trace the median class using this summation f over 2, because the median is the middle of this data set. So from the frequency, you use the sum of the frequency divided by 2, then you trace it from the cumulative frequency column where it falls. So this class is from 8, for this one is between 0 and 3. Anything within that class is there. This one once is above 3 to 8. This one once above 8 to 17, and that is where 15 falls. So that's why this is the median class. So everything we need, then this L stands for the lower class, which is this 15.5. Then the cumulative frequency is the sum of the frequency over 2 is 15 minus the cumulative frequency before that median class is 8 all over. This Fm means the frequency of the median class. This is the frequency column, which is 9. Then of course our class width, I've explained that before, is 5. Then you begin to slot them in. You do that, you do the addition at the end. You should follow the rule of mathematics. You now 15 minus 8 is 7 all over 9 times 5. 7 times 5 is 35 over 9. Then you divide that, then which is 35 divided by 9 is 3.89. Then you add 3.89 to 15.5, you will now get 19.39. So our median is 19.39. Now let me write the summary of the result from this group, from this data set, this group data. Now the summary of the results. The summary of the results. Our mean is equal to 20.83. 20.83. Our mode is equal to 18, and our median is equal to 19.39. You can see they are a bit close, not too far, but the mean is, you look at the classes now, the mode and the median, they fall in the same class. This class between 15.5 to 20.5, that's where the mode and the median fall. But the mean falls outside that class. The mean now falls in the next class. This is 20.5 to 25.5. That's where the mean falls. Why is it like that? Why did it happen that way? If you study the set of data, this data set, this group data set, you will find out that, look at from 31 to 35. The data set, the number of observations is 30. From 31 down to 40, we have just only 4 observations. It means that there's a tendency that an outlier, but it's not too pronounced, an outlier lies within the set of data. That is why you see the mean again falling out of the class where the mode and the median are. The mode and the median fall within this class between 15.5 to 20.5, but the mean has fallen outside of it. The mean is 20.83. But here, look at it now, it's outside this class. It's coming here. That means there is tendency that there are outliers. There are outliers in the data set. If you look at it from 31 down to 35, is just 1. From 36 to 40 is 3. So that means you have 4 data from 31 to 40. That means from 6 down to 30, you have 27. So you will see it from the, you have 26 from this particular, look at it, from this particular, from these groups up, you have 26 sets altogether, while the later end of it have just 4 in total, 1 plus 3. So there's tendency that an outlier exists in the set of data, and again, the outlier has shifted the mean away from the group they're supposed to be. But for this set of data, it is not too pronounced. So this is how to calculate the mean, the mode, the median for the grouped data. I hope you have learned something. Please subscribe to my YouTube channel, Dr. Chris Esekaigbe Mathematics/Statistics channel. Click on the bell button by the side of the subscription. When you click on it, anytime I upload a video, you will be among those that will get the notification. Share my videos on the link to the video to my videos. Share it on your social media platform. Share it on your WhatsApp status, your Facebook, and other platforms that you have. God bless you. I'll be coming again with measures of position. My next video will be looking at measures of position. We'll be looking at the quartiles, the deciles, and the percentiles. Measures of position. We'll look forward to it, and as you do, God will bless you. Share my video on your social media platform. Click on the subscribe to my channel, Dr. Chris Esekaigbe Mathematics/Statistics channel, and also click on the bell button so that anytime a video is uploaded, you will get a notification. Once again, God bless you. Thanks for listening and watching. Have a great day. Bye.